Hello everyone, welcome to my YouTube channel, and the question for today is design circular queue. So we have to design a circular queue. The circular queue is a linear data structure in which the operations are performed based on first FIFO structure. What does it mean is the element that moves first is the element that can be removed first only, alright? Unlike in stack, that is last in first out, where the element which moves in first is taken out last and vice versa. All right, so the queue structure is based on different principle, that is the FIFO one, and because it's circular, the last position is connected to the first position to make a circle. It's also called the ring buffer. So one of the benefits is that if the normal queue ones become full, we cannot insert, and even if there is a space in the front of the queue, but using the circular queue we can use the space to store new values. All right, so basically we have the functions k, which initializes the size, and front option that inserts the which will return the item that is present at front, and rear would last item, and the in queue will just enqueue, as the word suggests. It will add the element, dq will remove the element, is empty will check whether it's empty or not, and it's full, as the name will check it's full or not. Already, so we have to implement this. It's nothing but there can be two implementation of circular queue, one by a linked list data structure and another by array. Also we can implement using both of them. I'll be using the linked list one because it is quite frequently used, because it's a dynamic data structure, not like array, which is in which we have to define the size. So all right, so we will going to use the linked list representation, and let's see the constraints that are given over here. The constraint given to us over here are that the size of the k, the maximum size, could be from 1000. The value to be inserted will be from 0 to 1000, and at most 3000 calls will be made to these this. So we have to design our code like that. All right, so let's see how we are going to do it. So yeah, I have just used a linked list representation in which there are two variables, that is the value and the next. So the value will store the value that is present, and the next will be the pointer to the next node. All right, and this is the basic constructor. Now this is the code that has to be implemented. So I have taken two variables, maximum size and the current size. All right, so current size will increment based upon the how many elements are added and removed, and maximum size would be the one that would be initialized initially when the my circular queue function is called. All right, so yeah, though when this first its object is made, it would be called. Now moving on towards the function that are given to us. So the first function is enqueue1. Enqueue1 will does nothing, but it will just insert it. All right, so if it's full, that is if size equals to maximum size, then we'll return false, or else what we'll do is that we will make a new list node of that value and null, because we don't know what we have, where we have to add. And now if it's empty, then we going to initialize a new node as it is, or else we will just initialize at the end of our tail node. All right, and tail dot new is new, and tail is equals to tail dot next. All right, now the tail would be set to this node, and this node is already initialized with null, because if there is a linked list present, and if here is the tail, and if we have to insert a node here, so what we do is we create a new node with pointer to null, and then we point this node to this, and we move our tail pointer to next. All right, that's a simple operation in insertion in a linked list. All right, so yeah, I hope it's clear, this code is clear, and this is more of a theoretical question than rather than of coding. So it's just a theoretical based question. There is no some logic or like that, so that's why I'm explaining directly the code to you. Now the second operation that we have implemented is the dq1. All right, so if the queue is empty initially, so we cannot remove any element, so we will return false. And if it's not empty, then the head would be the beginning pointer in the linked list. It will be set to next, and the size would be decremented, and because if we have removed one, and we'll return true because this operation is performed. All right, similarly for front, So for front it would be just check if it's empty, then we will return -1 because there would be a no value at the front, or else front would simply return the head.val. We are not popping it out, we're just returning its value already, and here returns the value at the last. Is empty just checks whether the size is 0 or not, and is full checks that the size is equals to the maximum size or not. Alright, so yeah, size is incremented over here, maximum size is initialized over here. I hope this code is clear to everyone. Let's try to submit it. So as you can see, it's accepted. So if you have any doubt regarding any of the functions implemented over here, you can ask me in the comment section. Rest, please like this video, share it among your friends, and subscribe to my YouTube channel. Thank you for watching. Bye bye.